For binomial experiences, you have to have n, the number of times a trial is repeated, p, the probability of success in a single trial, q, the probability of failure in a single trial, and x, the random variable represents a count of the number of successes in trials. The requirements for a binomial experiment is the experiment is repeated for a fixed number of trials. There are only two possible outcomes of interest for each trial. They can be classified as a success or failure, and the probability of a success is the same for each trial, and the random variable x counts the number of successful trials. For success and failure, on surgeries, you have the first surgery, which can be a success or a failure, and then you have the second surgery, which can be a success, failure, or success, failure, and the third, which can be a success, failure, success, failure, success, failure, success, failure. And then you get the outcomes, which are here, and then the number of successes, and then the probability for each. The three outcomes have exactly two successes, each having a probability of 9 over 64. The probability of a success on exactly two surgeries is 3 times 9 over 64, which is approximately 0.422. An example of a question that is a binomial experiment is a survey asks 1,400 chief financial officers, has the economy forced you to postpone or reduce the amount of vacation you plan to take this year? 31% of those surveyed say they are postponing or reducing the amount of vacation. 20 officers participating in the survey are randomly selected. The random variable represents the number of officers who are postponing or reducing the amount of vacation. For this problem, n is 20, which is the officers that have been picked. P is 31%, or 0.31, who are postponing or reducing the amount of vacation. The Q is 0.69, which is 1 minus the 0.31. And then X is 1 through 20. And it is a binomial experiment, and it is a success is selecting an officer who is postponing or reducing the amount of vacation. Another example is annoying flights. The graph shows the results of a survey of travelers who were asked to name what they found most annoying on a flight. You randomly select 6 people who participated in the survey and ask them to name what they find most annoying on a flight. Let X represent the number who name crying kids as the most annoying. A. Construct a binomial distribution. So n is 6, q is 1 minus p, so the first part of A is n equals 6, and then q 1 minus p would be 1 minus 0.37, which is 0.63. B, find the probability that exactly 2 people name crying kids. So you use binomial PDF, and then you put in 6, 0.37, and 2, which gives you 0.323. And then C, find the probability that at least 5 people name crying kids. So you would do binomial PDF 6, 0.37, and 5, which gives you 0.026. Using a table to find the probability, you first find your n, which would be on this side, and then you find your x, which would be up here. And as an example, 29 and 0.30, probability is 0.065. Find the mean and standard deviation of the binomial distribution in exercise 31 and interpret the results in the context of the real-life situation. What values of x would you consider unusual? So this is mean, variance, and standard deviation. Mean is n times p, variance is n times p times q, and standard deviation is the square root of n times p times q. The mean is 6 times 0.37, which is 2.22. And the standard deviation is the square root of 6 times 0.37 times 0.63, which gives you 1.183. And the variance is 6 times 0.37 times 0.63. And that gives you 1.398.